Graphing parabolas, part 1. In this video, we'll graph the equation y equal x squared and compare the shape of the graph to the absolute value equation. Then we'll use the effects of constants to graph equations of the form y equals a times x minus h, the quantity squared, plus k. This is a screenshot from Desmos, a free online graphing calculator, and we have the graph of y equal x squared, which is called a parabola. A parabola is one of the conic sections. We have a picture of two cones, and the parabola is what happens when the plane cuts the cone at a special angle. A parabola has lots of special properties. You may have heard of a parabolic mirror. Light coming into a parabolic mirror is reflected off the sides, and all the light coming in goes to the same focal point. So that's a cool application, but what we're going to look at in this video is the graph and how to shift it around and what the effect of various constants are. So let's pay attention to the basic graph for a minute. You can see that it's symmetric about the y-axis here. This point down at the bottom is called the vertex, just like on the graph of y equal the absolute value of x. But instead of a V shape, we have a U shape. If we compare the parabola, the graph of y equal x squared, to the graph of y equal the absolute value of x, we can see that the parabola, the U shape, puts it below the V between 0 and 1, and then it climbs faster than the V shape after the point 1, and it's symmetric on the other side. So we have the same thing. Compared to the V, it's below from 0 to negative 1 and above from negative 1 to negative infinity. Using a program like Desmos to do some graphing for us lets us see the effects of various constants on the graph. So the red graph is y equal x squared, and the blue graph here is y equal x squared plus 3. You can see that the vertex of the blue graph is just shifted up 3 from where it was with the basic graph. And if I graph y equal x squared minus 3, I see that it's shifted down 3 from the vertex of the basic y equal x squared graph, and now it's at 0, negative 3. If I put the constant inside the square with x, the graph is shifted left or right, again, just like the absolute value graph. And it's shifted in the opposite direction from the constant. So here I have x plus 2, but the vertex of the graph is at negative 2, 0. And here I have x minus 2, and the vertex is at positive 2, 0. So inside the square shifts left or right, and it shifts in the opposite direction of the sign of the constant. Now my red graph is y equal x squared, but the blue graph is y equal x minus 2 squared plus 3. So minus 2 is inside the square, and that shifts my vertex over to positive 2. Plus 3 moves it up. So the vertex here is at 2, 3, the 2 from inside the square and the 3 from outside. If we multiply x squared by a constant, the graph of y equal 3x squared is narrower because the slope of this branch as it's going up is steeper. It goes through the point 1, 3 instead of the point 1, 1. If I put a negative 1 in front of the x squared, y equal negative x squared, my parabola just flips upside down. It's a frowny parabola instead of a smiley because it has a negative attitude. So again, the multiplier of x squared in this case, is changing the steepness of the graph just like a slope. Let's practice graphing a basic parabola by hand. So y equal x squared is the basic parabola. It has a vertex at 0, 0, and it goes to the point 1, 1 because 1 squared is 1. It also goes to the point negative 1, 1 because negative 1 squared is 1. And it has a U shape as opposed to a V shape for the absolute value graph. And it goes to those 2 points with a U shape. And then at 2, it's all the way up to 4. It starts climbing very steeply and it's symmetric on both sides. Now let's fancy it up a bit and graph y equal negative 2, there's our multiplier, x plus 3, the quantity squared, so the 3 is inside the square, and then plus 1 is outside. So let's see what those various things do. This 3 inside is the opposite of the x-coordinate of the vertex. And the 1 outside is the y-coordinate of the vertex. So my graph is going to have a vertex at negative 3, 1, and there it is. The negative sign outside here, the negative of the 2, makes the graph turn downward. So it's going to be a parabola facing down. Now if it was the same shape as y equal x squared, it would go through these points that are 1 away from the vertex, over 1, down 1, over 1, down 1, 1 away from the vertex. And it would look like that. But it's got a negative 2. So that's going to take those points, which were 1 over 1, down 1, and it's going to make them over 1, down 2. So instead of being the same shape as the basic parabola, it's a little steeper. Its U is a little tighter and it goes down more steeply. So that's how we use all the constants in the equation to graph the parabola.